Hello everybody, welcome to Mr. Aparicio's geometry course. I'm your teacher, Mr. Aparicio. Feel free to call me Mr. A. And I'm very excited to share with you video lessons for the entire subject of geometry. Before we get started, I want to wish you all a fantastic school year. I hope it's filled with great successes, great memories, and great learning. We will of course be starting with section 1.1 on points, lines, and planes. These are our building blocks for geometry. That word geometry, by the way, literally means earth measure. So a great way to think of this subject is the study of measurement. And we're eventually going to build to measuring two-dimensional shapes and three-dimensional shapes. So 2D shapes like triangles and rectangles, 3D shapes like spheres and cones. And in order to really understand those figures and how to name them and how to measure them and how to visualize them, we have to have a great understanding of these building blocks. So in 1.1, we're going to learn a lot of definitions. We're going to learn what things look like. We're going to learn how to name things and how to write the names of those things. If you're a student of mine here at UHS and you've received a packet of guided notes from me in class, make sure that you have those with you so that you can fill in the blanks and record any questions that you'll have for me in person. We're going to get started here with the point, which is the most basic building block in geometry. Points are how we name everything. This is very important to understand. The point is just a location. It has no shape or size, and despite not having shape or size, we can still draw it. What a point looks like is just a dot. So that's a point. In order to name points, it has to be labeled with a letter, and that letter must be capital, right? So I put a capital A, then I can call this point A. It's very important in geometry that we know how to read and write using geometry things and symbols. And when we're writing point A down, or when you're reading point A in geometry, the word point is never spelled. Instead, you're just given a capital letter. So in any readings that you do for geometry, if you come across just a single capital letter, it's understood that that means point A. Again, that's what a point looks like, just a dot. It's just a location. We're going to use it to name things, and it has no shape or size. Next, we have the line. A line is a set of infinite points that extends without end in opposite directions. Lines in geometry have to be drawn straight. They cannot be any curves. They have to be straight. So something like this can represent part of our line. The way that we show that this is without end and going on forever is by putting arrows on both ends of that straight line. So we have to have an arrow on both sides, two arrows, in order for it to be a line. So this is what a line looks like. In order to name a line or talk about a line, we have to have at least 2 points labeled on that line. So I'm going to go ahead and put a point R here and a point S here. And with these 2 points, I can name the line. The order of the points doesn't matter, so I could call this line RS or line SR. When we write the names of a line down, or when we're reading the name of a line in geometry, we have a symbol given to us. So that L-I-N-E will never be spelled out. Instead, we'll have a symbol for us. So line RS with a symbol would look like this, just a little line above R and S. So that reads line RS. Again, order doesn't matter. So this could also be called line SR. Now the only exception to this rule is if there is a lowercase letter next to one of our arrows. And this lowercase letter is typically either cursive or script. So if I put a fancy little lowercase m next to my arrow, I can now refer to this as line M instead of using the points. And if I'm going to write or read using those little lowercase letters, that is the only scenario where the word line is spelled out. So in this case, I would have to spell line M. Now lines can get a little confusing when we think about the infinite amount of points that are on them. There's more than just point R and S here, infinite points on the entire line. So if I labeled another point, T, it's important to understand how naming works in this scenario when we have more than 2 points. Okay? What we cannot do is use 3 points to name it. So I would not call this line RTS. Remember, you only use 2 points to name the line. When you have more than 2 labeled, you just have the freedom to use any 2 points that you want to name the line. So with the point T on there now, I'm free to call this line RT, or line TR, or line TS, or line ST, in addition to the 2 names that we gave it earlier. Very similar to a line is a ray, because this is also a set of infinite points, but instead of extending without end in opposite directions, it extends without end in just one direction. So like a line, a ray needs to be straight, can't be curved at all. But instead of having two arrows, it's only going forever one way, so it'll have one arrow at one end of the ray. And at the other end of the ray, it will have an endpoint. It'll show up there. So instead of an arrow on both sides, there's an arrow on one side, there is an endpoint on the other end of your ray. Like a line, in order to name a ray, we need to have at least 2 points on that ray, right? So we need a point on the endpoint, call that point A, and then we need a point somewhere else on our ray, right? So let's call this point C. Now for a ray, the order of the name matters. I cannot call this ray CA. The way we want to think of this is a ray that starts at point A and then passes C forever, so that A has to be the first letter in the name. So the only name for this ray is ray AC. The symbol that we would see when we're writing or reading for ray AC would be using those 2 points, and then drawing a little ray pointing to the right above it. So that reads ray AC. It's important to know that rays can be part of lines. So a line, or the line that we drew before, like this line has rays inside of it, right? There's a ray TS that starts at T and passes S forever, right? At the same time, there is a ray TR that starts at T, passes R forever, right? So rays can be parts of lines. Now, like lines, it's important to know how naming can change if we add more than that minimum of 2 points that's needed on our ray. So if I throw in a point D right here, it's important to know that we didn't change anything about the ray itself here, right? This still starts at A and then passes those points forever to the right. I just now get to choose what I want my second letter to be in the name. Still has to start with A, but I could also call this ray AD now instead of ray AC. And that would refer to the same exact figure here. The last member of our little line family here is the segment. So a segment can be part of a line, which I'll show you in a moment, but a segment is always bound by 2 endpoints. So there's not going to be any arrows on a segment. It does not go on forever. It's just a part, right? So it has a start and an end. So when we draw a segment, like a line or a ray, it's going to be straight. But again, instead of arrows, we need points, end points at the ends of our segments. So point here, point here. And those points are going to be how we name the segment. So we need letters there. I'll call this point L and this one point M. And we can now call this segment LM or ML. The order is not going to matter for the segment. Remember, the order matters for the ray, not for the segment or the line. When we're writing and reading segments, we will see a symbol. So if I call this segment LM and I'm writing that out, I would put LM and I would put the segment symbol, which is just a little bar above the L and M. So no arrows on that segment. Again, segments like rays can be parts of a line, right? Or they can be parts of rays as well. So we go back to this line. Again, in this line hiding are a few segments. There's a little segment right here, R and T. If I like chop everything off on this side and I chop all that off, there's just part of a line. So again, segments are just parts. Now, if we throw in an extra point on our segment, right? Let's say I put a point X right here, right? Naming here becomes a little bit more tricky. So we have to use the ends of our segments in order to name the ones that we're talking about. So LM here only refers to this whole part from L to M. If I were to write down the name segment LX, well, now I would only be referring to this part, everything from LX, not this whole thing from L to M. So remember, with lines, it's using any 2 points that can represent the whole thing because lines go on forever. For segments, there's starts and ends, so we have to use the points that are at those endpoints. So LX only refers to that little piece. Segment XM would only refer to that little green piece. A unique figure we have here in geometry is called opposite rays. So this is going to be 2 rays that share an endpoint and form a line. Okay, so we've already learned that rays go forever in one direction. So when we draw them, they would have 1 arrow, 1 endpoint. And so for opposite rays, we need to have 2 of these. But it's very important, they have to form a line with each other. So if I drew a ray sharing this same endpoint like this, that doesn't create a line. This, we will learn, is an angle. All right? To be opposite rays, I need to be going the exact opposite direction of this ray. So that would just be going here to the left, right? That will create a line. So this is what opposite rays look like. In order to name them, we're going to have 3 points labeled here. So that common endpoint would have to be labeled. We'll call that point A. And then we would need a point on either of the rays. I should say on both rays. So within this line, we now have opposite rays AB and AC. Both rays share point A, that's the same endpoint, and they form a straight line together, opposite rays. Okay, we've reached our first little exercise here where we're gonna try to identify all these figures that we've already discussed in this lesson. So again, we've learned about points, lines, rays, segments, and opposite rays, and all of those things exist here in this figure, and we're gonna see if we can find them all. We're gonna start with the points, and what I encourage you to do is just pause the video really quick and make sure that you can identify and name all the points in this figure. Okay, let's see if you got them all. In this figure are 4 points. Remember, points are just locations. They're always represented by dots, and we always label them with capital letters, and we have 4 of those here. There's a point A, a point B, a point C, and a point D. Again, A's there, B's there, C's there, D is there. 4 points. Next, pause the video and see if you can find and name all the lines that exist in this figure. Maybe you noticed I wrote line and not plural because there's only one line in this figure, but it can be named several different ways. Remember, the way we identify a line is with arrows on both ends, which only occurs here on this figure with an arrow at both ends. And remember, we only use 2 points to name the line, but it doesn't matter which 2 points, and it does not matter which order we put them in. So you could absolutely call this line AB or BA, or line BC, or line CB, line CA, line AC. All those names would be appropriate. Next, pause the video and see if you can identify all the rays that exist in this figure. This one might be a little tricky for you. All right, I'll see if you got this one. There are 5 rays in this figure that we can name. All right, if you said 3, you probably saw our obvious ones here. So there's a ray CD, absolutely. Remember, that's how we would write down the name for that. There's a ray CA. So we got a few here that start at point C. And then going opposite direction, there we have ray CB. But I wonder how many of you also saw this little ray that starts at B and goes this way forever, which we could call ray BC or ray BA. Remember, we think of it starting at B and passing those points forever. Remember, these can all be inside of lines. They're hidden in there. There's also this ray that starts at A and passes B forever. There's also a ray AB. Technically, there's more rays. There's a ray that starts at A and goes this way forever, but we can't name that ray because we don't have the second point there. There's also one going from B this way forever. Let's pause now to see if you can find all the segments in this figure, keeping in mind they're very similar to what we discussed with all the rays in this figure. All right, let's see if we got them all. Remember, we're looking for parts, just little parts in between 2 points, right? I think the obvious ones here are the smaller segments BC, CD, and CA. Remember, that order doesn't matter here, so for this red one, I could call it segment BC or segment CB. Gonna say BC for the heck of it. This one I could call segment CA, and that green one I could call segment CD. All right, but there is one other segment hiding in here which starts at B and ends at A, which we could call segment BA or AB. So 4 segments in our figure here. And lastly, we have 1 pair of opposite rays. Let's pause and see if you can find them. Okay, hopefully you remembered that opposite rays form a line together, and the only line we have here in our figure is right here, 2 arrows, and the opposite rays start at point C and go in opposite directions. So we have this opposite ray, CA. Remember, rays can only be named starting at the endpoint, so that's C passing A forever, that's ray CA. And then the opposite ray to that would be ray CB. So our opposite rays are ray CA and ray CB. Collinear is a common term that we're going to use throughout geometry, which just refers to things that are on the same line. So a lot of the things we've discussed so far can be things that are collinear. Points can be collinear, rays can be collinear, segments can be collinear. Again, just means things that are on the same line. So as we look at our previous little figure, there are a lot of collinear things here. Let's first talk about the points that are collinear. B, C, and A are all on the same line here. These are collinear points, right? B and D are not on the same line, so those are not collinear points. It's important to know that collinear can refer to 2 things, or it can refer to a group of things, right? So again, B, C, and A is a group of points that are all collinear. But if I refer to the group of B, C, A, and D, those are not collinear points because D, that one single point, is not on the same line as all the other ones in the group. So B, C, A are collinear, B, C, A, and D are not collinear. In addition to points, things like segments can be collinear. For example, segment BC and segment CA are collinear. They're on the same line. Ray CA and ray CB are collinear. They're on the same line. Ray CA and ray CD are not collinear. They're not on the same line. And by the way, even though we're saying linear and line a lot, things can be collinear on rays. For example, C and D are collinear. Even though that's not a line, they're still collinear because they're still on the same thing. Our next term to review is the plane, which is an infinite 2D figure. And this is a little bit of a hard one to wrap your head around, especially visually. Because you can't draw an infinite 2D figure. Remember, infinite means goes on forever. 2D figures means it would be going on forever in all different directions, right? So because we can't possibly draw that, what we do is we draw a four-sided shape to represent a plane. And typically that shape will look like this, kind of leaning over to one side. Although technically the plane is going forever in all directions, infinite, right? What we need inside of the plane in order to name it is at least 3 points. All right, so I'm gonna draw a few figures in here. Hopefully you all know that this thing with 2 arrows that I'm drawing is called a line, and I'm going to put some letters on this line. I'm gonna put A, B, and C. And then I'm gonna draw a random point D over here, and then I'm gonna put a capital R in this corner, which we'll talk about in a moment. So remember, to name a plane, I need to have at least 3 points. There's just one rule to follow here with these 3 points though, which is that those points cannot be collinear. You can't name a plane with points that are on the same line. So I cannot name this plane ABC. I can name it plane ABD, because those 3 as a group are not all on the same line. So plane ABD would work for a name for this. I could also name a plane if I'm given a capital letter in the corner. So not next to a dot, so this is not a point, because there's no point drawn next to it. If I have a capital letter alone like this in the corner, I can name the plane using it. So I could call this plane R. By the way, there's no symbol for a plane, which is why I spelled the word planes out. Now, the purpose of this rule about the points not being collinear, I'll try to visually explain for you here. So the idea is that any other flat 2D surface can also go through those points. So if you imagine this packet that I'm holding is just infinite going on forever, I could put it on the screen here and it would also intersect A, B, and C. So if I say point to plane ABC, I wouldn't know to point to my packet or the screen. Right? So this is why our 3 letters have to be non-collinear, not on the same line, because I cannot take another flat surface and put them on points A, B, and D. Those points are only on the screen, they can't exist on this packet. Right? Again, it might be hard to wrap your head around. Remember, anything that you watch here, if you have questions, write them down and come ask me in person, and I'll make sure to go over them with you. Just as collinear things are figures that are on the same line, coplanar things are figures that are on the same plane. So if you look at that plane that I drew for you previously, that line AC and that point D are coplanar because they are in the same plane. If I were to draw a point outside of this plane, say I added a point E down here, all right, then I would say that point D and point E are not coplanar because they are not inside of our four-sided shape that represents our infinite plane. So coplanar is things that are inside of our plane. If anything in our group is outside of the plane, then they are not coplanar. So we've reviewed all of our building blocks now for geometry at points, lines, planes that make up all of our 2D and 3D figures that we're going to be learning about throughout this course. Another important thing to discuss with these figures is the intersection of these things. So an intersection is just where things meet each other. The most common intersections that we know about are streets, like the intersection of Rhode Island in 1792 on your way into UHS. All right, all of these figures that we've discussed so far have intersections, and it's important that we're able to identify where the intersections of these figures are. So the first intersection we're going to look at is an intersection between a line, segment, or ray. So if any of these things meet each other, they meet at exactly 1 point. Let me draw an example of that for you here. So this is a line. This is a segment. And remember, an intersection is where those things meet. And these things meet, they only touch right there at that location, which is a point. Remember, points are locations. So any of these things meet each other, they intersect at a single point. So you can be asked throughout geometry, hey, identify the intersection of this line and this ray, and you have to be able to name that. So the intersection of these two would be right there at point A. Another type of intersection that we need to be able to identify is one between a plane and a line segment or array. That's what this L, S, and R is. So if a line segment or array intersects a plane, they intersect at exactly a single point. Okay, a single point is where they would intersect each other. So let me draw a plane for you. And we represent that with a four-sided shape like this. Right, and I could draw a line going through this plane, and I'm going to try to do this in a way that you can visually comprehend. So I'm doing this, a little dot here, and then I'm going to go dash, 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 and then draw the rest of it over here. What you can imagine this as is like a sheet of paper with a pencil stabbing through it. Like the only place those would meet is at one single location. The rest of the pencil isn't touching the paper. That little dash part is just representing something that you can't see, like it's behind the paper. Can't see that part of it. But yeah, they only intersect at one single point. Again, that plane intersects this line at point A. The one that's a little bit tricky for you to visualize is what happens when two planes intersect each other. And what I'm going to do first is try to visualize this with you with a screen and this little packet. So remember, planes are infinite 2D shapes. We usually use four-sided shapes to represent them. So I have this four-sided packet, my four-sided screen. If I were to put this packet on the screen, right? Remember, the intersection is where they meet, where they touch. And they don't just touch right here, right? They don't just touch over here, but they're touching at all of these locations on our plane. And remember, our plane goes on forever in both directions, right? So again, what's my stylus? So again, if I put this up here on the screen, it wouldn't just touch at one corner, like right there. It wouldn't just touch over here at this corner either. It would touch at all the points in between, extending forever, which makes a line. So planes intersect always at lines. Right, I'll try to draw a little example of this for you here that hopefully you can visualize. So here's one plane, four-sided shape. I'm going to draw another plane like this, four-sided shape. And again, these planes are not just meeting right here, and they're not just meeting right there, but they're meeting at all the points in between. And remember that planes go on forever in all directions. So this would be infinitely meeting each other. And that line would be the intersection of those two planes. It is important to note that this can be drawn a few different ways. It doesn't have to look exactly as I've drawn it here. Sometimes this will be drawn with the arrow shown, showing you that this is a line that they're intersecting at. In other scenarios, though, it could be drawn in different ways. This could be drawn as a ray. Like I could just ignore this part over here. You might see the visuals of a figure of a ray drawn. Most commonly, what we'll see, though, is three-dimensional shapes where the intersections are just segments. They're just shown as segments. For example, I'm going to draw a cube right here for you guys. And the intersections of all the planes here are segments, no arrows at all. They're just bound endpoints. So this is a preview of how our three-dimensional shapes are made in geometry. They're made by planes. A bunch of planes intersecting each other create our three-dimensional shapes. This concludes our video lesson for section 1.1 on points, lines, and planes. Remember that you have to have your guided notes filled out, and we will spend time in class practicing, identifying, and naming all of these figures. If you have any questions, please make sure to write them down in the section provided for you in your packet and be ready to ask me those in class, and I'll be happy to help you out so that you can master this content. All right, we'll see you guys in class, and we'll see you in the next video. Bye, guys.